Now we're going to learn about what are called the limit laws, okay? And these are rules that all limits follow. And they're probably going to seem very abstract right now. But the good news is that we really learn about three big things in Calc 1. We learn about limits, then we learn about derivatives, and we learn about integrals. And the really cool thing is that they all follow very similar rules because they actually all come down to these limit laws. Okay, so we'll see things very similar to this throughout the course. So the first one says, if you're taking the limit as x goes to a of f of x plus g of x, so you're adding two functions together. Well, it tells us that we can actually take the limit as x goes to a of f of x, then add it to the limit as x goes to a of g of x. So we can kind of take them separately and then add their answers together. Okay, subtraction, the same thing. If we want to take the limit as x goes to a of f of x minus g of x, we can take the limit as x goes to a of f of x and subtract the limit as x goes to a of g of x. Okay, multiplication works exactly the same way. So if we want to take the limit as of f of x times g of x, we can take the limit of the first one and multiply by the limit of the second one. Okay. Now sometimes we'll have something like the limit as x goes to a of a constant times a function. So that c represents something that's just a number, a 5 or a 2 or whatever. And what's really cool is we can actually pull the constant out front and multiply by it. So we can do c times the limit as x goes to a of f of x. Okay, dividing, just like we've seen, we can take the limit of the top and divide by the limit of the bottom. Now, dividing, we always have to be careful. We have to make sure that that limit of the bottom is not 0 because so as long as this does not equal, the line there does not equal 0, we can do that. Okay, now looking at 3, when we talked about multiplication, if we want to take the limit as x goes to a of a function to a power, we can actually take the limit as x goes to a of f of x and raise that whole limit to the power. So let's, in very simple ways, put these laws into action. Okay, so don't know why this blue line's there, but it says, assume that the limit as x goes to 3 of x squared equals 9, which this is one of those cases if you looked at the graph at x squared and you looked at the y value at 3, it's 9 and it's nice and smooth. And you can see if you plug 3 into x squared, you get 9. Okay, and it also tells us that the limit as x goes to 3 of x plus 3 is equal to 6. Again, if you plugged 3 in for x, you would get 6. Okay, so part A asks us to find the limit as x goes to 3 of x squared plus x plus 3. Now, from the two functions we have right now, think of this as like f of x is x squared and g of x is x plus 3. Then we can think of this like asking for the limit of f of x plus g of x, right? This was f, this was g. And our limit law told us then we just had to add the limit. So our limit of x squared was 9 as x goes to 3, and our limit of x plus 3 was 6. So here we have to be going to the same value, limit as x goes to 3, but we find that our limit is 15. And if you actually just plugged 3 in here for x squared plus x plus 3, you would get 15. Okay, here we want the limit as x goes to 3 of x squared minus x minus 3. Well, we can think of this like the limit as x goes to 3 of f of x minus g of x, because if we took x squared and subtracted x plus 3, which we'd have to put in parentheses, when we distribute the minus, we would get x squared minus x minus 3. So here we would take the limit of x squared, 9, minus the limit of x plus 3, which is 6. So our limit would be 3. Okay, this next one, we're multiplying f times g. So our limit laws tell us we can just multiply their limits. So 9 times 6 is 54. Okay, the limit as x goes to 3 of 3x squared plus 2x times x plus 3. Well, this is like 3f plus 2g. Okay, and we could do this step by step and write it all out, but what we can actually do is just take the 3 times the limit of f of x, which was 9, plus 2 times the limit of g of x, which is 6. So we'd have 27 plus 12, which would give us 39. Okay. This next one, the one we haven't done yet, is dividing. So we've got f divided by g. So we can just take our limits 9 over 6, which we could reduce down to 3/2. Okay. And our last one here says, is telling us that the limit as x goes to 7 of x cubed is equal to 343. And it says find the limit as x goes to 7 of x to the 6th. Well, what we kind of have to figure out is how does x to the 6th relate to x cubed? And it's actually x cubed squared, because remember when we square, or have an exponent on an exponent, we multiply them. So 3 times 2 would be 6. So here we want to take the limit we already had, 343, and square it, which I'll pull out my calculator here. That gives us 117,649. Okay, so again, the limit laws aren't something that we'll use that much in practice, but it's good to see if we know some simpler limits. If we are adding those functions together, we can just add them, subtracting the functions, subtract the limits, and so on.